Okay, so we are going to look at chapter 1 for the review. So important things here, scientific and the standard notations, and then the math skills. Okay, so this is an opportunity for me to test your your preparation for in your prerequisites, whether you know the basic maths rules and whether you can do the conversions, whether you can understand or interpret the graph. So here let's do some of the questions from the book. So here you are given problem. So this is on page 23. Page 23, and here you're given a problem 1.49. Okay, 1.49. Express the following numbers in scientific notation. So you're given part A. This one is, this problem 1.49 is 1, 2, 0 and 0, 0, 0. Okay, so in this case, what will we do? We need to, this is a standard notation. So we know that there is a decimal present. The decimal is right here. So from a standard to scientific notation, 1, 2, 3, 4, and 5. Move the decimal to 5 places. 5 places to the left. Okay, so now what the answer becomes? 1.2 into 10 to the power positive 5. Okay, so this is how you have to show on the exam, all the details, how this is done, how the problem is solved. Okay, next thing is, let's look at another question. It is 0.0000034. Okay, now here write the answer in the scientific notation. So this is 1, 2, 3, 4, 5, 6, and 7. So you moved it 7 places to the right. So in this case, the answer now becomes 3.4 into 10 to the power negative 7. Okay, so that's one piece. Next, let's look at some of the questions that relate to your math skills. Okay, let's do this one. So page 23, 1.46. Okay, so the question here is negative 95. Okay, negative 95 minus 11. Okay, so what is the answer here? So in this case, we are testing whether you know the basic math skills. That minus multiply by minus, what does this become? Minus multiply by minus becomes a positive. So basically, this thing is going to be translated as positive. So now you have, next piece is negative 95 plus 11. So now the next rule is that negative and positive is going to be, when you add negative and a positive number, when it's added, it becomes negative, but the sign is of a big number. Sign is always of a bigger number. So now we have, in other words, 95 minus 11. This is what it means. So what do you get here? 95 minus 11. Negative. So 95 minus 11 is equal to negative 84. Negative 84. Okay. Negative 84. All right. So somebody wrote it negative 85, but that must have been the typo. Yeah, Eddie, thank you. All right. So that's one piece. So this is something you should know. Okay. Similarly, when it's dividing, it will be a negative number. When it is, let's look at this one. This is 1.45. 1.45. Okay, 1.45 is negative. So this is part C. negative 168 divided by negative 4. So what do you get? So in this case, minus and minus cancel out. So the answer is going to be a positive number. So the rest is 168 divided by 4, and you get a positive 42. Okay. Got it? So these basic rules you should know. Next is this type of rules. Next is, let's see if you can do some of the let's do this one. Again, 1.47. Okay, this is a parts to whole problems. So let's see. A bag of gumdrops contains 16 orange gumdrops. So there is a bag, and that bag contains 16 orange ones, orange candies, a bag of candies contains 16 orange candies, 8 yellow, and you are given 16 black. Okay. Now, what is the percentage of yellow candy? Yellow candies. How many? What percentage? So it's my dogs. Okay. Yellow. What percentage? Nanu. Oh God. Okay. Yellow. So how do you do? How much? So in this case, this is a part, small parts. You're going to be doing these questions. Why are we doing this? This is your basic, excuse me, parts. Sorry about that. Okay, yeah. Parts over the whole. Okay, times 100%. So why are we doing this? You are going to do the questions on moles. Okay, so moles, like the number of carbon atoms present in a sugar molecule. That is why you need to have this understanding, right? Hi. Yeah. Okay, excuse me, guys. And it's okay, don't worry about it. It's okay, don't worry. Can you just close the door, please? Little one, yeah. Thank you. Don't worry about it. Thank you. Okay, sorry, guys. Okay, so here we have the yellow. Yellow is 8 yellow over the total. So the total is what? 16 plus 16 plus 8. Nanu. 16 plus 16 plus 8. 16 plus 16 plus 8. And that is total of 40. Okay, 40 candies times 100%. Okay, so let's do this. So 8 divided by 40 times 100. So you should know how to do these type of. So this becomes 20% are yellow candies. Okay, so this is the answer. All right, guys. So this is one piece from here. And the next is let's look at this one. Let's look at a graph, and then we will move on. So I'm going to look at this challenge question. Oh yeah, there are other questions also. So following, let's do this one. 1.54. Now here you have 3z minus 6 is equal to 12. Okay, so a question like this can be asked on the exam. Find the value of z. Like I said, I'm testing your prerequisite math skills also. So how do we do this? So we know that these are the like terms. This is like and this is like. And for now, this one is an unlike term, right? So like terms on one side and unlike on the other, first of all. So how will we do this one? So we know that minus minus becomes plus. So actually this is, sorry, This is actually 3z plus 6 is equal to 12. Okay, so bring 6 on the other side of the equation. So we have 3z plus 6 minus 6. So we need to cancel 6 from here so that you can bring 6 on one side of the equation. So minus 6. So this cancels out the 6. Now, why are we doing this? Because you're going to be using these, you know, in, let's say, like when we do, what is it called? The gas laws. Okay, for the gas laws, you would need this. Okay, now here, 3z is equal to 12 minus 6 is 6. Now we need to bring now this number. Oh, sorry. You need to bring this number and this number, you know, together. So you should know that the we see that the z is multiplying with 3. So if you divide by 3, so that cancels out a 3. And so here, 3. Okay, so next is these two cancel out, and then this becomes simplified as 2. So z is equal to 2. So here you need to show all steps, even if it's trivial, even if you say, oh, I used my mental math and got it. But no, you have to show all the steps. How did you do it? You know, see, that's a problem with multiple choice. Students can guess on the multiple choice and get the answer and then say, oh, I used mental. There's no such thing as mental math. Okay, you have to show all the working here. But once you get like some kind of like very deep into the chemistry, then it's, but for or elementary courses, you have to show. All right, here is a very interesting example. Now, let's do this problem. So this one was actually 155. Okay, and this relates to graph. Now, graphing is very important in science, especially when you do the graphing for like in the gas laws, you will be doing a lot of graphing, you know. So there, it helps us see the relationships between the variables. That's one piece. Second thing is that we also can extrapolate, right? We can find out like if for the unknowns. Okay. Now here you are given, they have given solubility. So solubility, how much, you know, things are going to dissolve in a certain liquid and so forth. So the solubility, grams of carbon dioxide, grams, and this is, we are talking about CO2, grams of solubility in 100 grams of water, 100 grams of water. Okay, so carbon dioxide, if you take 100 grams of water and you bubble carbon dioxide into it, so we see that it is temperature dependent. It depends on the temperature, degree Celsius. So always here, it's very important that the units are written, always. Units are very important. Okay, always write the units. Okay, without that, these numbers don't mean anything. Now, what do we see here? We see a graph that looks like this. All right, so more or less like this. Now, here, the question is that, let's say, and then let's see some values are given here. 1, 2, 3, 4, 5, 6, 7, 8, and then 1, 2, 3, 4, 5, 6. And I'm going to just put some numbers here. This is, let's say, I'm going to just put here 1, 2, 3, 4, 5, 6. Okay. And then here, this is 10, 20, 30, 40, 50, 60, 70, and so forth. Okay, so this side, when you go, you see that the temperature is increasing. The temperature is increasing at the bottom, but the solubility is decreasing. So this is one interpretation of the graph, that as the temperature increases, as the temperature, degree Celsius, as the temperature is increasing, here you see that the solubility is increasing, but as the temperature is increasing, we see that the solubility is going down, right? And let's say on the exam, let's say on an experiment, you are able to use some data points. Only you were able to gather some data points, but the other ones you will have to use the graph to interpret. So let us say room temperature, what is the solubility of carbon dioxide in 100 grams of water at room temperature? So room temperature will be given like here, somewhere here. It's 26, okay? 26 right here, 26 or 25. So you go up like this, keep going up like that, and go back to check. So it is somewhere between 3 and 4, right? So you go up and then like that. So here we see that at 26 degrees Celsius, the solubility is somewhere in the range. So you sometimes have to guesstimate a little bit between 3 and 4, but more towards the 4 side. So it could be 3.6 grams of CO2 dissolves per 100 grams of water. Okay, got it? So this is, in this thing. Or you can also do like at what temperature is the solubility of carbon dioxide 2 grams per 100 grams of water, at what temperature? So you will have to see at 50 degrees from this graph. Okay, so you will have to just move your fingers and figure out. So at 50 degrees Celsius, the solubility is 2.0 grams, all this. All right. So the units are very important. Without the units, you don't see. So you see the units here. This is a unit. This is a unit. This has a unit. So 26 and 50 has a meaning. And that meaning is we are looking at the temperature. This is also a unit. Sorry. This is also a unit. Grams of some certain thing, something, this whole thing is a per. So these are also the units. Okay. And now we are going to look into the next chapter, chapter 2, where we are going to look at these units and the conversions of the units. Okay. All right. Now, next chapter. So far, so good. Any questions so far? Any questions, anyone? No problems, right? So my recommendation is just sit down and just casually, if you're struggling with the math, casually review the algebraic conversions, the sheets that I have given, or from your previous book, whatever works for you, just look at those and then you'll be fine. Okay, because we are going to use all this in this. We are going to use all this in this course. Okay, all this information. Now, chapter 2, measurements. Now, what is important here? As I told you, that significant figures, most important thing. Now, some students, now that's the thing. Some students just, you are still learning. Okay, Tan. May you do another problem similar to graphing? I fully don't understand how to do it. Okay, Tan, we have a lot to cover. So I cannot just, get stuck on this. So graphing is, we will have to discuss this later. Okay, I can do it with you one more time because I have a lot of other things to cover. So this is a review so that if there are certain things you don't understand, you stay after class and we will go from there. Okay. All right. So otherwise I won't be able to cover things. Okay. Next is chapter 2, measurements. And we talked about significant figures, the most important thing here. Okay, so let's write down so what are the important things here? Number 1, significant figures. So significant figures. Okay, now significant figures are significant figures. Okay, everything, the rules regarding the significant figures, calculations, right? Everything about them. Next is the conversions, all the conversions that relate to dimensional analysis. And then the last one is that the density one, so these are very important. Now, here, please keep your handout ready with you. On the handout, I have tables. So on the exam, I may give you the tables, I may not give you the table, I may not give you the equality, but these tables have the equalities. So you are going to refer to these equalities to do the conversions. Okay, now, rules regarding the significant figures. So you should know what are the rules are. So all the rules are, like, even in the handout, I have given you the rules. Okay, even in the handout, there are the rules. And these rules are, let's do a review. Okay, what are the rules? Rules for the significant figures. No, no. So first, just general rules. General rules. So one is that all non-zero numbers are important. On zero numbers are significant figures, right? Next is the zeros that are in between the numbers. Zero in between the numbers. Those are called captive zeros. They are significant figures. They are counted. When we say rules regarding, so these are basically counting those zeros. Counting means that they are included in the, like, counting means they are included in the calculations or in the measurement. Okay, so here we see counting significant, so that equals to, okay, so all the zeros that are in between the numbers, significant figures. Then comes the zeros that are the zeros, wherever the zero is present, in a decimal number. If there is a zero, if there is a decimal number, and if there is a zero in that, but zero is in front, zero is at the back. So let's look at these. So rules regarding the decimals. If there is a decimal, right? There is a decimal and there are zeros in the numbers, but zeros after a number. Okay, then that means that is counted. It's significant. But if the zero is before the number, zero before a number, in that case, it is not a significant figure. It is not counted. Clear? This is very important. And the last one is the exact numbers. Now, this is a mistake students make. This is a mistake students make. And the mistake is that they don't understand the exact numbers and they make a mess here. So the exact numbers are not significant figures. Do not count. I'm going to write this in red. Do not count the exact numbers in calculations. Okay? In computation. In computation means when you are calculations, in computations. Okay? Do not count exact numbers in computation, like when you're calculating. So even though, why? Because these exact numbers have variable significant figures. So for example, we talked about 10, let's say 100. 100 can have one significant figure, two significant figure, three significant figure. How? 100 can be written as 1 into 10 to the power 2. 100 can also be written as 1.0 into 10 to the power 2. And 100 can also be written as 1.00 into 10 to the power 2. You see that? So it depends who is, you know, how much sensitivity is there in the calculation and who's doing the calculation. So sometimes you just need that one. Sometimes you need two significant figures, like one place after the decimal. Sometimes you need two places after the decimal to be more sensitive. Remember, the more the places after the decimal, the more sensitive the calculation is. You know, so you get that, everyone? So that's one thing. The next rule is rules regarding rules in computation. Rules in computation. So what are the rules when you are calculating? Rules in computation. So when you are adding and subtracting, what happens? When add and subtract. Okay, add and subtract. So what is that rule? Okay, so what's going on here? So if there is 0 after a number, but not in a decimal like 20, then the significant figure is 2, right? Okay, so what's going on here? So trailing zeros count if there is a decimal point. If there is a, yeah, that's true. Trailing zeros count. And Harpreet is asking if there is a 0 after a number, but not in a decimal like 20. Like 20, then the significant figure is 2, right? Okay, no. What am I saying? Okay. Okay, so hold on.
Professor?
Yeah.
I meant to say 1. I didn't mean to say 2. So like 200, that's just gonna have one significant figure number.
No. That's
No?
what I'm trying to explain. That's what I'm trying to explain. Hold on.
Okay.
All right, so this is one example. Second example. Okay, let's say instead of 200, 2000. So one number is this, and another number is this, 2000 point. When we say 2000 point, what does that mean? That means that all these zeros are going to point, because anytime there is a decimal, that is going to be counting. So this one will only have 1, 2, 3, 4, 4 significant figures and nothing else. But in this case, the decimal is there in 200. In 200, the decimal is there, but it's implied. In this case, the decimal is there, but it's implied. So this is an exact number. This is an exact number. Oh God. This is an exact number. This one. So exact number always, where the decimals are implied. Okay, you understand implied decimal? It's there. It's right here. This is the implied decimal. It's not written. Okay, and so implied decimals is that the implied decimal is so it's just 2000. So this can have variable significant figures. Okay, and what are those? So 2000 can be written as, remember that implied decimal can be moved. So it can, like if you can write that number in scientific notation. So this can be like 2000. Let me do this here. When you change the decimal, so decimal is here 1, 2, and 3. So this becomes 2.000. And you moved it 3 places to the left, so it becomes this. You can write like this, but it depends. If you don't care about the 3 places after the decimal, you only want 2 places after the decimal, then it becomes 2.00. Let's say you don't even care about 2 places after the decimal, just 1 place after the decimal. See, the exponents are still 3. That's not changing. It's just the number of places after the decimal. Let's say you don't even care about, ideally, scientific notation is always like 2 digits and then a 0 and then a decimal in between. But sometimes, you can also write this number like this. So you see all these. So in this case, 1, 2, 3, 4, there are 4 significant figures. In this case, there are 3 significant figures. In this case, there are 2 significant figures. And in this case, there is only 1 significant figure. So you see variable significant figures. So this is the reason why we do not count them. Exact numbers. Okay, exact numbers are not counted while doing calculations. Okay, computation means calculation. Now, what kind of calculations? Have you guys understood now? Any questions?
Professor?
Yeah.
I was just like basically asking that because I remember we had this significant figure worksheet where we're supposed to like see how many significant figure numbers we have, right?
Yeah.
And then for one part it says 990 and
yeah,
answer
okay.
was
So from
2.
that worksheet questions ask me in the worksheet. I know, okay, there are certain things missing from that worksheet. See, worksheet questions I do on purpose. Some of the, because worksheets, okay, some of those worksheets do have like either there is a mistake or the questions are like incomplete information. So whenever there's a worksheet, I expect the students to discuss those answers with me. The answers are already given to you, right? So people can just write the answers. And then, but once a student is discussing the worksheet and specific questions, then I come to know that they are thinking, they're doing the work. They're not just copying the answers.
Yeah.
So that's the reason why some of the worksheets are for practicing and discussions, right? And you guys have the time for that. So anyways, so now let's look at this question from the worksheet. You said 990, right? 990. So here, 990, that's a good question. 990. It was 990 or something else?
Yeah, it's 990.
Okay, so anytime, so this is an exact number. Exact numbers means, once again, variable, significant figure. So what type, how many times? So your book must have given you, like in the worksheet, how many were given? 2. So here's the thing, 990 means 990. This means that 1, 2. 2 places. You can move the decimal to convert a standard to a scientific. 9.90 into 10 to the power, how much? 2, right? So here you have 3 significant figures, but you can drop that 0, depends, who is doing the calculation, how much sensitivity you want to have in the calculation. So the more sensitive is obviously the ones that go certain numbers after the decimal, but less sensitive are the ones, like this. So this is the 2 significant figures. And, I mean, ideally, this should just be 2 and 3. 2 and 3. Yeah, it can't be 1 significant figure. It cannot be 1 significant figure, because if you have to like round up in order to make that, and then it just doesn't work like that. So this will have 2 significant figures. That is why variable. Clear?
Yeah.
What did he give you?
Yeah, so like that one's 2 significant figure numbers. I didn't know that, but I was just trying to make sure for like 200, is it going to be 1 or what? That's what I was trying to make sure.
No, 1 is not. No, 1.
Oh.
See, okay, you also have to have use some kind of so when you do these calculations, you kind of get a grasp of, like have some kind of like a number sense. Okay, number sense is okay, number sense is like, first of all, it always depends in what context the calculation is being done. So 990, let's say 990 guests are coming to some big event, and they want to put some or they want to have some food cooked for 990 people, right? This is an exact number, 990. So if they're cooking the food, now if a chef is there, so for them, a chef can round up. 990 can be rounded up, right? So round up 990, what does it become? What does it become? 990 rounded up. Yeah. Roughly, rounding up roughly, like in the mental math, 1000, it's easy to do the calculations from using 1000, okay? So from mental math, this estimation works. And who is using it? If a chef is using or someone is just guesstimating something. So for estimation, this is a good thing to do. But then if someone wants to put some chairs, right? Or someone wants to sell some tickets, right? So that has to be exact number, 990. So in that case, rounding up doesn't make sense, right? If you only have 990 chairs and you want to have 990 people coming in, sitting on those chairs, the extra, you can't sell any extra tickets. 990 is just, so those three, for them, those three significant figures are important. So it's three significant figures is important for them in that case, right? So it depends, like it can be three significant figure, it can be two, but it obviously can't be one, so that's the way to do it. But see, a lot of it we have covered in the lectures also. So for more stuff, if you want, you should just review the lecture videos also, but we need to move on. Okay, now let's look at some of the problems from the book. I'm going to do some difficult questions here. I'm doing these additional problems now. Let's look at these. Oh, sorry. There's something we didn't cover, and that is what is the addition and subtraction. Addition, rules regarding addition, subtraction. So what is that rule? Addition and subtraction. So anytime the final answer, you count the decimal places. Now this is, see, okay, I have taken the test in other classes also, and show the decimal places. Okay, don't just assume, show the decimal places so that the final answer will have the decimal. So count the decimal places, the final answer will have the lowest decimal place, the final answer. Lowest decimal place, the final answer. So this is one rule. And next is the multiplication and division. What is the rule? You count the significant figures on every, and then the final answer will have the lowest significant figure. Do not count what you should not count. In the calculations, do not count what? Yeah? Exact numbers. Perfect. So do not count the exact numbers. Now, exact numbers. When you are doing the calculations. Okay, let's look at some of the problems now. Okay, here are some of these questions. And then rounding off and all that you go. Okay. Okay, so here you have 2.83. 2.83, and this is page 58. Now, these are all difficult questions, challenge questions, that section. Okay. A dessert contains 137.25 grams of vanilla ice cream, 137.25 grams of vanilla ice cream. Okay, and then there is 84 grams of fudge sauce, 84 grams of sauce, okay, and 43.7 grams of nuts, 43.7 grams of nuts. Okay, what is the total mass in grams of this dessert? So find the total. And that means we have to add these. So anytime you're adding, so lay out the problem like this, the way I have written, and then here, write down the decimal places. So show the decimal places. So this is 2, write down here. Okay, why am I doing this review? If I don't see these details, I'm sorry, I'll have to deduct your points. So this is your decimal place. You don't have to write down this big number, like big DECIMAL. You can simply write down D2, like DPL, and that's okay. So as far as I see this, I'm okay. So pay attention to this. I have deducted points because students actually, in addition, they're doing addition. And what are they counting? Significant figures? No, you need to count the decimal places. So this one has 0 decimal place, and this one has 2 decimal place. But, the 84 is an exact number. So what do? We just don't even consider it. So we are just going to consider these 2 decimal places. See, here's the value in decimal places. Decimal places, like there is, remember accuracy and precision, more accurate. When you place certain things on a machine, let's say weighing machine. So if it has 1 place after the decimal, if it has 2 places after the decimal, if there are 3 places after the decimal. So the one that is showing 3 places after the decimal, that is more sensitive, more exact. You understand that? So it's more sensitive to the calculation, more exact. So the more the places after the decimal, the more sensitive the calculation is, or the measurement is. So it's not like the less there are, the better. So that is why we ignore the exact numbers, because they don't have the decimal. So now we are going to add. So 137.25, let's add these. So 137.25 plus 84 plus 43.7. And this gives you, so write down the raw answer as you see in the calculator. So the calculator is showing 264.95. Okay. 43.7. Oh, sorry, it should be 1. Yeah, it should be 1. Thank you. 1. Yeah, it should be just 1. 43.71. So your answer, the final answer, should have only 1 decimal place. But here, this is what you get from the calculator. Write down what you get from the calculator and then work around it. So we need to keep 1, we need to drop 5. So when you drop 5, what happens to 9? Nine is 9, you add 1 to 9 and it becomes 10. So that means the 4 will have 4 plus 1 becomes 5. So here's this thing. So 265.0. Okay, so that's, you will have to round up in order to get 1 decimal place. And this 0 has a value. There is a value of this 0. Okay, there is a value. of the zero. It is when you do the measurements, you can see on a ruler, 0.1, 0.2, 0.3, 0.4, 0.0. So that means 265.0. That's where you up to that level or whatever you're trying to measure, that 0.0, the machine or the instrument or the equipment should read 0.0. You get that? Or, I mean, ideally, I'll be honest with you, in chemistry, rounding up creates problems. Rounding up is only beautifying the problems, beautifying the numbers. Cosmetic fixture of the number. 164.95 looks like comparatively cluttered in comparison to 265.0, right? So 265.0 is more cosmetic fixture, okay? Cosmetic fixture. Okay. So this is like if now here's another thing. If you see 264.95, the question will actually say up to the significant figures. The question will tell you up to correct number of significant figures. So if the question is specifically saying significant figures, then yeah, then you choose this answer, because you need one place after the decimal. But if the question is saying, doesn't talk about significant figure and you're working in the lab, it's always a good idea to keep the numbers as is. The mass, especially mass or the volume, that because we're dealing with matter and every little drop has like a certain number of atoms or molecules or ions or whatever, we are trying to measure that piece is there. So we cannot create, or we cannot downsize the matter. Okay. All right. So this is one piece. Next is, let's look at another example here. Where else is the to multiplication. I think it's let's do some multiplication problems. I don't see them here. Let's get them from the book. Multiplication. Here. Okay. Let's do this problem. 2.26 and this is problem C. So, and this is on page 35. Page 35. Now here you are given 0.825. Okay, multiply by 36, 3.6, multiply by 5.1. Okay. So this is given to you. And in that case, you are given, in this case, multiplying. So here you will look at the significant figures. So here the 0 in front is not counted. So this is 3 significant figures. This is 2 significant figures. And this is again 2 significant figures. So your final answer should have 2 significant figures. Got it? So let's do this one. 0.825 times 3.6 times 5.1. And that is, so write down the raw answer from the calculator. And then we'll work with those numbers later, cosmetic fixing later. Okay, calculator is reading 15.147. All right, 15.147. But we need only 2 significant figures. So we need to keep this, we need to keep this. But this one and all these others have to be dropped. Okay, so when you're dropping these, because 1 is less than 5, the other 5 remains as is. Okay, so the answer now is, the final answer is 15. Again, this is cosmetic fixing only. Okay, clear? So that's with the multiplication. So show all the details, at least show, if on the exam, you have to show these details. So show this, showing, and then what the answer should have, at least to write that down, whatever calculator answer you get, whatever it is, and then do all this, rounding and write the final answer. So this thing, all this, you will have to do on a separate sheet of paper. Okay, now, prefixes. Now, this is now let's look at some of the conversion factors. Okay, conversions, we will do like all in one. Looking at questions from the back here. Let's see. Yeah, I'm not going to make it too much of a math oriented here, but using, 1 second. Okay. Okay, let's do this one. 2 point, so this is the problem, 2.58, and this is on page 49. Page 49. Okay. Now, this relates to the people who are going in the nursing program. So you should know how to do these type of conversions. Okay. A physician has ordered 1 gram, 1.0 grams of tetracycline, antibiotic, tetracycline. Okay. To be given every 6 hours. So every 6 hours, in 6 hours, 6 hours, to a patient. 1 gram. So in other words, this whole thing, 1 tetra is equal to, this becomes the equality. So 1 gram of this, I'm going to call it med, MED. So 1 gram of med per 6 hours, or 6 hours, these are the two conversion factors, per 1.0 grams of med. So you see, from the reading, the language, from the sentence, you can derive these equalities. Okay. Okay. Next is, if your stock on hand is 500 milligrams, so 500 milligrams is in stock, 500 milligrams tablet, 500 milligrams tablet. So this means 1 tablet is 500 milligrams. So 500 milligrams is equal to 1 tablet. You see that? So how this is translating? And this means 500 milligrams per tablet. That means 1 tablet, or 1 tablet. So again, the two conversion factors, per 500 milligrams. All right. And again, it's the 5 milligrams of medication. So milligrams of med. All right. Next is, how many will you need for 1 day's treatment? 1 day, for 1 day. How many tablets should be given? So you see that 6 hours, so something, 6 hours to a patient. So 1 gram in 1 day's treatment. So 1 day, 6, so how do we do this? The tablet, 1 tablet is 500 milligrams. And we need to give, in 6 hours, we need to give 1 gram. So that means we need to give 2 tablets in 6 hours. right? So let's do this here. So let's count this here. First of all, how many tablets in 6 hours? How many tablets in 6 hours? Okay, so per 6 hour. So so we have 1 gram. So 500, one tablet. Yeah, one. I'm just setting it up mentally. I have it. 1 gram of medication per 6 hours. And then there is 500. No. Yeah, convert the grams to milligrams first of all so that they can talk. So so we have 1 gram is equal to 1000 milligrams, right? And so then we have 1 tablet, 6 hours, right? So this will give you how many tablets will be in 6 hours. And then we also know here, let's do this here, 6 hours, and in 1 day, I don't know how 1 day they are calculating as 24 hours, I think. So will this go 24 hours? So 1 day, hold on, just let's get this one. I'm going to just stop the recording for a minute through this one. Okay, so the question was how many tablets in 1 day? So we will have in 1 day how many tablets, and assuming that 1 day they are looking at as 24 hours. So this is 24 hours making 1 day. Okay, is equal to 1 day. So here we see one thing, the doctor has ordered 1 gram of tetracycline per 6 hours, every 6 hours. And the tablets available in the stock are 500 milligrams, 1 tablet. So first thing is we need to equalize the units, grams to milligrams. So we take grams is equal to 1 gram is equal to 1000 milligrams. So you take this conversion factor, cancel out the grams, and you get a milligram. So this is 1000 milligrams is being given in 6 hours. So this is, you converted that. So this 1000 in 6 hours. Now, how many tablets is that? So 1 tablet is 500 milligrams. 1 tablet is 500 milligrams. So 1000 milligrams will cover 2 tablets. So 2 tablets will cover 1000 milligrams. Okay, now the question is in 6 hours, we are giving 2 tablets. But in 1 day, which is made up of 24 hours, how many tablets will be given? So you take the 2 tablets over 6 hours times 24 hours per day. So per day, that's in 1 day. So hours and hours cancel, and then you get this answer. Okay, so this is the way you will do this type of conversion. The other conversions are like, for example, okay, let's look at this one. So this is again a little difficult one. 2.56, and this is page 48. Okay, here they are giving you page 48, and here they are giving you a wine is 12% alcohol by volume. So wine is 12% alcohol by volume. Okay, now right here, I'm going to tell you 12% alcohol by volume. What does that mean? It means 12 milliliters of alcohol And because wine is made up of other things also, so 12 milliliters of alcohol is present in 100 milliliters of wine. This is what it means. It can also mean, because we are talking about volume, so it can also be something else. It can also mean 12 liters of alcohol is present in, so these percentages are flexible, right? 12 liters of alcohol are present in 12 liters of wine. Oh, sorry, in 100 liters of wine. Okay, so that's the deal with the percentages. 100 liters of wine. Okay, next is the question is, and so forth. So you can, you know, milliliters, microliters, deciliters, and so forth. So that's how you translate the percentage. Okay, so it's flexible. You can just put any of the units in there. So just make sure that the total, it's always, the percentage is always, it's a problem of parts to whole. Small part of a big whole times 100%. Okay, so that is the how you translate the percentage. Okay, let's look at the question next. How many milliliters of alcohol? So the question is, how many milliliters of alcohol, are in 0.70 liters? So the total, so alcohol, and the total wine given is liters, 0.750. Yeah, 750 liters wine. So how many milliliters of alcohol is present? So remember that in this case, a few things, and this type of question can be asked on the test, and that is, this is in milliliter, this is in liter. So what are you going to do? You need to equalize this. Either you convert the whole thing into liter, or you convert the whole thing into milliliter. It doesn't matter which one you go. So there are a few things here regarding the percentages also. So remember, these are now the conversion factors. These can be used as a conversion factor. So like I said, so if let's use it milliliters. So first thing is convert 0.750 liters to milliliters. And you can do otherwise also. So something that you can find from the table, or you should know, that 1 liter is equal to 1,000 milliliters. All right, 1 liter is 1,000 milliliters. So this means 0.750 liters multiplied by 1,000 milliliters over 1 liter. So this cancels out the liters. And what do you get here? You get 750 milliliters. Okay. So this is the first thing. This is the total wine. So total wine is 750 milliliters. Now, next thing is they're saying how many milliliters of alcohol is there. So this 12% alcohol now becomes the equality. So 12% alcohol becomes a conversion factor. This means 12 milliliters of alcohol is present in 750 milliliters of wine. Okay, we're going to use this conversion factor. Okay, so next thing is, just write down here 750 milliliters of wine. Okay, multiply by 12 milliliters of alcohol. 12 milliliters of alcohol over 750 milliliters of wine. All right, so you see the wine and wine cancel out, milliliters and milliliters cancel out, and the question is asking how many milliliters of alcohol. This is what you need to find, right? So milliliters has to be there. So now Oh, sorry, I made a mistake here. This is 100. This is 100. This is 100. 100 milliliters. So this is that 12% translated like this. 12%, you know, that is given, gets converted into the conversion factor like that. Okay. So this was given. Right. And so 750 times 12 divided by 100. And that gives you 90 milliliters of alcohol present in 750 milliliters of wine. Okay, so this is how they label the things also. Okay, and so then is a density problems are also going to be there. Let's do one problem on density, and then we'll start the next chapters. So 3 and then 4. No, sorry, what did I do here? .56. Okay, let's do a density problem. Okay, here the density. Oh, I want to do one where there are some conversion. Yeah, okay, let's do this one. This is an interesting one. Stop. Okay, here is page 53. Page 53. Okay, page 53, and this is problem 2.66. 2.66. Okay, here. So part C. Okay, here a fish tank holds 35 gallons of water. Okay, using the density. So given density of water is equal to 1.00 grams per milliliter, right? Determine the number of pounds of water in the fish tank. So how many pounds of water is present in the fish tank? Or in other words, 35 gallons will make how many pounds of water? So we are going to look for a conversion of gallons to pounds. Is there a direct conversion of gallons to pounds? You check the tables that are given to you. Okay, gallons to pounds is not. There's no gallons is gallon is a unit for volume, right? And how many pounds? And pounds is a unit for mass. So gallons, so you should recognize this. Gallon is a unit for volume. And they're asking us for pounds. And pounds is the unit for mass. So the only way you can convert volume to mass is by going via density. And density is density. Density is mass over volume. That's the formula. Okay, so this is the strategy. So in this case, first things first, 35 gallons need to be converted to grams so that the gallons and density can talk to each other. So first thing, the gallons, 35 gallons is how many grams? Okay, because they are not the same. The gallons need to be converted to how many grams? Okay, then the grams need to be cancelled out using the density. So grams will cancel out using the density. And that's going to give you the milliliters. And then milliliters need to be converted to, no, sorry. What am I doing here? Wait a minute. Gallons is a volume. We need to convert gallons to milliliters. Sorry. Milliliters. Okay, gallons to, how many milliliters is that? Hold on. So this is what we will do. Gallons, first of all, convert to milliliters. Milliliters using the density cancels out. We are left just with grams, and then grams to pounds. But when you look at the table, from the table of the equalities that is given to you in the handout also, what do you see? You see that there are some, so 1 gallon is equal to 4 quarts. This is known, okay? And then the quarts need to be converted to 1 liter. 1 quart is 2 pints. 1 milliliters. Yeah, we can convert the quart. So let's write down all that. Quart. So 1 quart is equal to 2 pints. 2 pints. Okay, 1 quart is 2 pints. And then 1 pint is equal to 473 milliliters. Okay, so let's do this first. So here we see 35 gallons. Okay, times 4 quarts over 1 gallon. So gallon and gallon cancel out. Next, let's get rid of the quarts. 2 pints. 1 quart. So that cancels out the quart. Next, 473 milliliters, 1 pint. Okay. So that will convert the gallons to milliliters. So this way, if you see the gallons and gallons, quarts and quarts, pints and pints cancel out. All right, so let's do this here. 35 times 4 times 2 times 473. And that is a big number, weird number, but big. 132,440 milliliters. Okay, so one thing, you've converted the 35 gallons to this number, milliliter. Okay, next step is you are going to cancel out this. So next step is we are going to convert this whole milliliters to grams. So milliliters to grams, and then grams need to be converted to pounds. So milliliters to gram is going to go via density. Okay, let's look at the relationship between grams and pounds. So we know that 1 pound is equal to 454 grams. So 1 pound is 454 grams. So let's do this now. Sorry. So 132-440 milliliters times the density is 1.00 grams over 1 milliliter. Okay, so we see here that the milliliter and milliliter cancels out. Next thing is convert the grams to pounds. So 1 pound is 454 grams. And they want the answer in pounds. So you stop here. So this cancels out the grams. You see that? So 132,440 times 1 divide by 454. And you get 291 0.71 pounds. Okay. So that's the way you will do. So I've like, the rest of it is all practice, but that's the answer. All right, so the rest of it is all practice. So this finishes chapter 2. Now chapter 3, let's see. So this is going to be a big review, but chapter 3. So do you want to take a break, a little break? Just 5 minutes, 5 minutes break, okay? Let's take a break. And I'm going to actually stop recording here. Next recording, we are going to do the, start the next recording, okay? For the chapter 3 and 4.